In this lesson, we are going to take up one more problem on spring block system. The problem is simple, but we'll do the calculations very smartly and get the answer very quickly. Here is a spring of spring constant K equal to 600 Newton per meter. This is connected to a cart CART of mass 6 kg. On top of that cart, we have a mass M. In the first part of the question, it is given that M does not slip on the cart and the time period of the system is 0.75 seconds. If we pull this by some distance x and release it, the time period of oscillation is 0.75 seconds. We have to find mass M. So that is very easy. We know the formula for time period of a spring block system. Time period will be 2 pi root over total mass, this plus this, because they are moving together, M plus 6 divided by the spring constant K. We have to find M. Now, if we write time period as 0.75 second, squaring that will be difficult. But if we write time period as 3 by 4 seconds, because 0.75 is 3 by 4, then squaring that is easy, very easy. So we can write this as 3 by 4 equal to 2 pi root over M plus 6 by the spring constant, which is 600. Now squaring this is not difficult at all. We get 9 by 16 equal to 4 pi square and M plus 6 by 600. Pi square is approximately 10 and here we get 15. So now therefore M plus 6 becomes 9 into 15 by 16. 9 into 15 is easy, it is 135. So we get 135 by 16. If you know the tables of 16, well and good, we can divide directly. If you don't know, nothing to worry, we can divide by 4. So we get 4 here and we get 34 here, approximately. And now this division is easy, we get 8.5. So this is 8.5 and therefore M is 2.5 kg. So the first part of the problem is solved. We have found M and we have done all the calculations very easily. We wrote 0.75 as 3 by 4. Squaring that was easy. We wrote pi square as 10 and that made calculation easy. And then we did some approximation and got the answer. Now the second part is, if this cart is pulled by 50 millimeter, that means the amplitude is 50 millimeter, and released, what should be the coefficient of static friction between M and the cart so that M does not slip on the cart, and that means they move together. So now since we know the time period as 0.75 seconds, we can calculate omega, the angular frequency. Angular frequency is 2 pi by time period. So we get 2 pi. Again let us write 3 by 4 for time period. So we get 8 pi by 3. This is the angular frequency. Now if this is omega, we know acceleration is given by minus omega square x. So therefore the maximum acceleration has a magnitude omega square into a. So this omega we have to square. 8 pi by 3 whole square into the amplitude, which is 50 mm. So 50 into 10 to the power minus 3. So now we have got magnitude of acceleration. Now therefore, this is the maximum acceleration that these blocks will have. So this m also has to have this acceleration, maximum acceleration. And this acceleration it is getting because of the frictional force. So therefore, the frictional force mu s into mg must be equal to mass into the maximum acceleration that we have here. So this will give us mu s. So this m cancels. So mu s becomes a divided by g. A is this 64 pi square into 50 into 10 to the power minus 3 divided by 9 into that g which is 10. So pi square and 10 cancel out. 64 into 50 will give us 320. Okay. 3200. And that if you multiply by 10 to the power minus 3, we'll get 3.2. Okay, so basically 3.2 by 9. So mu s is 3.2 divided by 9, and that gives us 0.355. So this is the coefficient of static friction required between the mass m and the cart. So basically we knew the time period. From time period we calculated omega as 2 pi by time period, and after we got omega, then we found that the maximum acceleration has a magnitude omega square a. So we found omega square a, and then this block accelerates because of friction, because it's not connected to the spring. Only thing that can make this top block accelerate is the frictional force, and that frictional force is mu s mg, maximum value of frictional force, and that must be equal to mass into acceleration. Therefore mu s becomes a by g, and therefore we get mu s as 0.355.